Hello, everyone. Very good day, good afternoon, good evening, based on wherever you're tuning in from. We are back with yet another episode of Rancher Life, and it's been a while since we caught up. The last time I believe we all were here together was earlier in June. So I think a lot of us have not really had the time to sort of congregate and stuff like that. Um, I'm gonna ramble for a bit because I've been out of touch. Today I'm very excited to bring on my guest for the day and for this session, primarily because this session was inspired by one of the sessions we had previously around Project Acri. This was in May. If you've actually not watched that, you can do so. Where you can do so after this session. In that session, we had Nicholas. I hope I'm getting the name right. Um, he's one of the maintainers of the project, but he also works with us at Susa. So we had delved a bit into Project Acri and around and the definition around edge computing, and a bit about what Acri does in this space. This is sort of a follow up session. I wouldn't say it's directly connected, but it was inspired by that conversation. And I'm really happy to sort of bring on this guest, who I shall be bringing on in a little bit. But before we go ahead, I also ought to set the ground rules for this session, primarily because we're all here to learn, we're all here to share knowledge. So I would request that whenever we're interacting with each other on chat, we be courteous to one another. That's the first thing. And the second thing is, I know we might have some questions, as one always does during such sessions. So please reserve them for the end by actually entering them in the chat section so that I can relay them to our guest. Speaking of whom, I think it's about time I bring him on. So hello, Jason, and thank you so much for taking our time today and joining me on our Ranch Live episode.
Yeah, thank you for having me. I'm going to add good morning to your list of introductions because I am East Coast US and it is 10 a.m. for me. So you said good morning, afternoon. I'm going to represent the East Coast here. I'm going to say good morning to everyone. So you said good afternoon, good evening. I'm excited to be here. This is very cool.
And that's why I start off with a blanket good day, because it's night. If you can't see behind me, it's like pitch dark. It's at least getting to be pitch dark now. So I just start off with a blanket good day for that very purpose. But it's so nice to have you on here. And it's really really cool that we're gonna nerd out on some awesome stuff that you've been working on. But first, Jason, I think we ought to give people a sense of what you do here before we go ahead. So, do you
Sure.
want to introduce yourself?
Yeah. I love that you said nerd out. That's such a great tone for this. So my name is Jason Dobies. I've been at SUSE for about a year and a half now. I'm a director of engineering in the Edge team. We are a small new team in SUSE, really ramping up to answer what we've had on our radar for a while, or what the company's had on their radar for a while in terms of Edge and the growing landscape and the possibilities there. Prior to that, I've had a couple different jobs, some really long running, awesome ones, some disappointing ones, but the common theme has been open source. I've been working with open source software for probably 18-ish years now, probably a little bit longer if you kind of add in just hobbyist type of stuff. So this whole realm, Rancher, Live, SUSE, all of this is very much a home for me, being able to do things in the open like I'm used to.
Yeah, and today's theme is building for the edge, and I know that you do work with the edge engineering side. This is just a thing that I do whenever I talk about edge, because I've noticed that. There are quite a few definitions of the term edge computing floating around the internet. Like, depending on who you ask, they have a definition. So, I would really like to understand your definition and what we work with as part of our day jobs.
Yeah, yeah, it's a great question because it's going to be one of those things like cloud where you ask five people and you get somehow seven different definitions of it.
Right?
So
Yeah.
I'm always happy to have a chance to kind of say my take on it. So the easy definition is anything outside of the data center, but that's a bit of a cop out. I don't want to leave it at just that. But I've been doing in this industry long enough where I've seen us solve quite a few of the data center problems. There's still some scaling issues and power and so forth. I'm not saying it's completely solved, but anything outside of that has thrown a wrench into a lot of existing paradigms. I think Nicola probably introduced on his talk, which by the way did a great job of refreshing from his talk. Let's talk about Akri and the IoT of things. He probably mentioned the near, far, and tiny edge, and the idea
Yes.
that there's kind of different granularities of how far away from the data center you are. And each of those has their own challenges and their own uses. So near edge, smaller scale, likely a larger data pipe, but near, as in it's fairly close to your data center and not many hops away from it. And then you get to this idea of this far and tiny edge where now you're talking about very remote systems, low bandwidth or no bandwidth. You'll hear me mention the word air gapped a lot over the course of the next half an hour because it's been a bit of the bane of my existence trying to kind of engineer around it. And I shouldn't even say my team because they have done a lot of the hard work there. But also device size as well. We're looking at cameras and sensors, and honestly, the more customers I talk to, like they're showing these really cool demos. We had them at the Rancher booth last KubeCon in North America, of all these nice little fiddly, like tinkery type stuff, and watching it all get monitored and cataloged. And that's at a scale that we're not really used to when we're talking about anywhere from a coffee shop with 35,000 locations to a grocery store that doesn't really have a dedicated IT department. So or in some cases is not even necessarily that close to civilization if you think about something like cell towers. So you don't have Bob in IT who can walk over and debug something or provision something. And that causes a lot of complications, really neat stuff that we've been trying to solve. But like I said, it changes the landscape a bit from the data center because you've got a couple of kids working as a barista. They don't really need to be admitting a Kubernetes cluster sitting in the back room of that coffee shop. So we're looking at how do we handle those situations? How do we give you visualization and idea of I'm going to manage these 35,000 boxes or 35,000 devices. Boxes is even the right word. I'm still using the old terminology here. All of these devices in such a way that you can see them, you can understand them, and then and I'll start cutting it off here, but I've mentioned retail now. I've loosely alluded to telco. There's also things like the Internet of Things. There is healthcare, which has its own set of complications as well, because that sensor that is running in a hospital, that again, you're going to have an IT department on staff, but they need to know immediately. There is no kind of leeway for, oh, this poor guy's medicine went down. We'll get to it within a 4-hour SLA. He'll be fine, I promise. So how do we manage that? How do we understand all of the devices in there and making sure they're working correctly? So very long, drawn out answer, and I'll try to keep my answers a little bit shorter going forward.
That's fine. But one of the questions that I think you didn't really touch upon, or maybe one of the points you didn't really touch upon is adminning and or rather administrating the Kubernetes cluster, and potentially even managing, not even managing, like managing the deployments of course is a thing, but like provisioning those clusters from the very get go, right? That in itself would be a challenge, like provisioning not only in terms of resources and everything else, but in general, like having those workloads, cloud native workloads especially, run on these edge devices that are not really in a data center would be a challenge. And I think our topic of discussion today is geared around that, if I'm not mistaken.
No, you're definitely right. And thank you for compensating for my nerves in this whole thing and for getting the lead into my actual topic. So I did talk about the kind of inventory and the awareness play, but again, if you don't have someone on site that can provision them, what happens when you ship a whole bunch of machines out to a site, or what happens when I buy from a manufacturer who's going to pre-provision something that needs to connect back into my enterprise so that way I can administer it. All of that has, again, a series of complications, which is something that, to finally get to the product point of things, the Edge platform is looking to solve. Now, you mentioned earlier about Nicolas stuff being related to this. It's such a big space, and the Edge platform is so large that I could probably go the rest of this talk without talking about Acri and the specific things. Um, but to give an intro to what we're going to be talking about today, it's that provisioning step of I have a machine, I need to get it provisioned. Okay, we have ways of doing that, but I don't need it to just have an operating system. I need it to have workloads on it. I need it to be part of some kind of cluster. I need it to be checking back in. And again, remember what I said earlier about air gapped and low bandwidth situations. We're not really in a world where we can say, take a default SLE micro ISO, boot it up, and then run zipper update and grab a couple hundred megs worth of data. And that's before you've started provisioning your Kubernetes cluster and your workloads and things like that.
Yeah.
And that's not to mention all of the manual process around that. And that's what Edge Image Builder, the topic we're going to talk about today, is going to cover. So let me know if you want me to just dig into that now, or do you want to do a little more kind of Edge platformy stuff? Happy to talk about whatever.
I'm happy to go either way because now we've started with the Edge Image Builder stuff. I think it would be worthwhile to actually dive right in and talk more about the idea behind the project. I know you covered a lot of it just like a couple of minutes back with the provisioning bits, but essentially, what in the Edge Image Builder actually and the what components within the Image Builder actually help solve that problem? Could you like dive a little more into that?
Sure, sure. So I talked a bit about motivation, and let me tell you now about what we're trying to solve. So to get around the network bandwidth, to get around the potential air gap situation, to give people a repeatable GitOpsy way of provisioning these and building the images and the workloads and so forth. We sat down as a group of us in a room in the UK and decided, okay, really what we would like to do is just jam all of this stuff into the image at the outset. So instead of a first boot running and giving you a fresh, clean install that you have to go and do a bunch of things to, in the data center, you can solve that in any number of ways where you boot that up and then you have a remote server that connects into it and configures it or runs any number of half a dozen different configuration type things out there right now. But that wasn't good enough given a lot of our constraints. So we talked about, let's take it and what if we include all of that information into the image itself that is shipped around? Now that gives us a way of rebuilding the image to exactly the workflows. So one button later, I have the exact same image that was used to provision these 1,000, 5,000 machines without having to know, okay, after that we ran this script, and after that Billy went in and decided to change his configuration and so forth.
Yeah.
So what Edge Image Builder is, and credit to a guy on my team at Thomas who saw this at the very beginning. In hindsight, we probably should have named it Edge Image Customizer. But we take a base SLE micro image, and before it's actually booted, the base image, either the self-installing ISO or just a plain raw disk image, and we customize it to include pretty much anything you would want to do as you deploy this out. So we started with the management cluster. Edge platform, we can probably, I could spend a half an hour on that alone, but it has a management cluster as you would probably expect. And that has Kubernetes and Rancher and SLE Micro, but it also has workloads on there for a lot of these provisioning tasks. There's the whole bare metal provisioning of there's some machinery over there, turn it on, provision it. I'm not going to talk about that flow at all today, but that is one piece. There's the visualization, there's KubeVirt and so forth. So all of that goes into the management cluster. We said, okay, what if we take all of that information, we stick it inside the image in such a way that when the image first boots, it's going to run through the install and configuration of all of those pieces at the get-go. And that way, once it finishes booting, now my node is not only up and running, but it has everything I possibly want on it. Longhorn, Rancher, and so on. So that was for the management cluster. And then we decided, okay, well, I shouldn't say we decided. We knew from the get-go this was also going to be used in a number of different cases. I mentioned earlier the idea of sending something to a manufacturer and they burn it into the hardware before they send it out. You can use Edge Image Builder to customize that with the call home URL and authentication credentials or however you need to, so that the manufacturer doesn't really need to know anything. They're just given an image and that's it. We're not telling them do these extra post-install steps, run this side script, and so on. They take that image that comes out of Edge Image Builder, and I'll come back a little bit more about what it is and how it works in a second. But it will take that image, burn it on, and then again, when it boots, it goes through all of the configuration at first boot. So it will call home and register into Rancher and say, hey, I'm one of your clusters, you can now manage me. Excuse me. So the main idea was let's keep any kind of post configuration out of the equation. Let's embed it in the image itself. Now that gets easy for certain things. We have operating system level configurations. I need to add users, SSH keys, disable systemd services. We have some more complicated aspects of that of RPMs. And this is where, as I say that, I'm sure one of my engineers is sitting in a corner right now crying because he was the one who worked on this and this was not easy. But we talked about the air gap situations. So I want to install an RPM on this node that started. That RPM may have dependencies. In fact, it likely will have dependencies. So what Edge Image Builder will do is I tell it, I want you to install this RPM when the node is booted. But Image Builder is also going to figure out, okay, to do that, I need these 5 dependent RPMs, or I need these 50 dependent RPMs. And all of those are included in the image as well. Every time I explain this, it sounds like, yeah, that makes sense. And again, one of my engineers is like physically, like he grew his first gray working on it. It was very impressive. We're all very proud of him. So RPM installation with dependency resolution. And that was absolutely the key thing there because it doesn't do us any good in an air gap situation to embed 1 RPM and then have it try to install and say, hey, I need to download another 300 gigs worth of dependencies. So want me to keep going down this path?
Absolutely. I mean,
Cool.
I think this is a very interesting path to follow. So yeah,
okay. Just making sure. I can talk as long as you give me. So I want to make sure you never know the direction you want me to go in.
No.
Okay, so there's the operating system level configurations. Obviously, Kubernetes installations. You can pick K3s or RKE2. You can define the configurations for it just like you would any K3s or RKE2 clusters. So the same files you would use, you drop them in, they get deployed on the nodes. And here's where things really get cool is a single node K3s installation is awesome for a developer. When I started at Suson and initially installed K3s and it was up in like half a second, I was like, this is life-changing compared to like previous distros I've worked on. But really you need an HA scenario. But you can still do that in one image in Image Builder. There's a way of defining how I want my HA cluster to be deployed. And I can specify which nodes function as the servers, which nodes function which nodes function as the server, which ones function as agents. And something I haven't said yet that I probably should have, this is all done through one image. So if I do this right, I don't have 5 separate images, one for each of the 3 HA control plane and then one for each agent. These are all a single image that gets deployed on the node. When it boots, it figures out, oh, I'm supposed to be a server, or oh, I'm supposed to be an agent, and here's the server I call back to. And it automatically configures itself that way. And that was one of the things that we absolutely wanted. We did not want this massive image sprawl of 35,000 machines. We don't want 35,000 images floating around there. So I did see a question in the LinkedIn user that call home function works with elemental. That's exactly the call home function it is. You put the elemental config inside of this image builder, inside of your image definition, and then when the image gets built, it reads that elemental configuration and calls back and registers itself. Good question, anonymous LinkedIn user. Thank you for leading me in something I forgot to mention. So we have our HA Kubernetes clusters. We have networking. Networking is similar in the sense that you don't need one per node. We have ways of defining it and saying, these are all of the nodes it's going to be installed on, and here's the network configuration that should apply to each node. Again, one image, multiple deployments, and your enterprise, as they stand up, they coalesce into exactly what you've defined. I feel like I'm blanking on other functionality here. Hold on, I get my slides on the side to cheat with. We have the ability for...
Display them on the screen by any chance? We can do that.
Yeah, you know what? Let me... Oops. No, you know what? Not yet. We can go back to that. Okay. I may show some kind of demo if we need to. So networking, Kubernetes, custom files, and then obviously all of our Suson bits. So Longhorn, Rancher, all of those pieces can be installed as well. That is just in the 1.0 release of Edge Image Builder. I guess I should say this now too. Fully open source project, available on GitHub. Not sure your mechanism for sharing links out to the users here, but if you were to search around for SUSE Edge Image Builder, you'll probably land on our repository easy enough.
I will make sure to include that in the description later on, Jason. Don't you worry.
Cool. Cool.
And I'll have that included in the LinkedIn and the YouTube description, so y'all can go check that out. And the GitHub repo and whatever other links you want me to include as part of the session. So don't you worry about that.
Awesome, awesome. Yeah. So anyone who does okay. Let me finish that first train of thought. In the 1.0 version, which released in April, really has only been around since last September. I have been lucky enough to work with some phenomenal engineers who produced pure magic in that short amount of time. So all of that is available in the 1.0 release, which is itself available in the Edge 3.0 release. Like I said, GitHub project, open source. If you do play around with it, please... PRs are welcome, issues are welcome. Too difficult to solve, in which case don't file them because I don't like bugs that are tricky. That just gives me a headache. So your nice trivial ones like, Jay, you misspelled something, I'm happy to do that. I do see a question. In a full air gap environment, will a connection to a Rancher manager server always be required? Yes. So not required isn't the right word there. You can absolutely deploy a completely standalone node with a image built from Image Builder and its customizations. But like you said, yes, Rancher can be air gapped. So it's important to remember, in my head, when I hear air gapped, I think, oh, it doesn't have access to the internet, therefore it's on an island. It's literally air gapped. But realistically, air gapped deployments will probably have some kind of intranet. So we can do, and we've seen running fully air gapped in the sense that the cluster itself, the Rancher cluster, the management cluster, and all of its child nodes have the ability to connect within themselves and then just stay off of the public internet. That does look like what Reese is answering as well to that. So yeah, the air gapped, keep in mind that I tend to think air gapped is single node, burn a CD, walk it over, make sure that, no one's holding a gun. I worked in the government for a little bit, so I'm very nervous about all this stuff. But it's not. It can be just full-blown Rancher deployments that just stay off of the public internet itself. Keep going with the questions. I love answering them in real time. But to give you a little more details.
I have a question now. When it comes to hardening of the clusters, right? Like, because typically, if you're working with air-gapped environments, hardening of whatever cluster, whether you're talking about K3S or RKE2, how does that work? Like, when you're talking about, the Edge Image Builder actually sort of installing this and hardening the cluster, especially when it comes to K3S install that has been facilitated by Edge Image Builder.
Yeah, so I mentioned earlier air gapped giving us all a little PTSD. SE Linux also did once we started adding that into the equation. It's able to be flipped on as part of the image definition, and when you're building the image. After that, we're able to really rely on the products themselves. So K3S, RKE2, Rancher, Slee Micro, they all have their own hardening guides that we're able to play nicely with, for lack of a better term. You can do the configurations necessary to enable that to the level. And that's what we have so far. We have our eye on things like SBOMs and FIPS compliance and so on, that are coming, or at least in a research phase. But it's great that you mentioned the hardening, because one of the things I didn't mention earlier talking about edge is that security takes a different perspective when you're out on the
Perspective.
edge. You
Yeah.
don't have the sense of, you always have the possibility that someone runs behind the counter and grabs the box and runs away with it. That's not really a data center problem unless your security is really bad. But in a lot of edge deployments, you're not looking at these kind of secure situations. So it has been kind of paramount to all of Edge, including Edge Image Builder, but all of the Edge platform, to take those kind of hardening things into consideration. And this is going to sound like such a company shell here, but we get to leverage all of the great work SUSE has done on its products and support that, and be able to turn it on and then let them kind of do their thing, and all of the hard work that those guys have put in toward it.
Yeah, I think that answers my question. Thank you.
Yeah.
And I'm sorry to cut off your train of thought, because I know that there was something awesome there. But do you want to, get back to that, if you remember where we were?
Yeah, so one quick thing I want to talk about is what it looks like to use. So I could pull up a demo. It's admittedly, I've presented a lot of demos, and for all of the cool stuff I mentioned, it just, as a demo, you're like, cool, it built an image, ta-da, and I could boot the image and show you all this stuff exists, and it always falls a little flat. So I'll just kind of more describe it. You end up with a single definition. It's a YAML file, because we are in the Kubernetes world. We're all YAML developers these days. And it defines everything you want inside of that image, from your K3S version to your SSH keys for your user to the systemd services you're disabling. You provide a directory as well with all of the extra files you want to add. The elemental config that was mentioned earlier, any
Yeah.
RPMs I want to sideload, the configuration files for Kubernetes, and any custom scripts I include. All of that's passed through a CLI tool that runs inside of a container itself. So the install instructions were probably some of my favorite documentation I've ever written, because it's podman run this, done. We don't have 1,000 different steps to do it. It has saved so much, because some of the things we do in there to crack open an image and edit it would be a nightmare if people had to install the dependencies.
Truly, yeah.
But you feed the directory and the definition into the CLI tool. Out pops the ready to deploy image at that point, or the customized ready to boot image at that point. That image is going to be an ISO that you could burn to a USB stick, or you could feed through any number of provisioning types of mechanisms. Edge platform supports those. Again, I don't want to talk about that, especially since we're running low on time, but that could be a really cool follow-up talk, is to talk about our bare metal provisioning steps. But you could also get a raw image out of it and simply write that to the disk. As it boots, it uses combustion to use the files and the scripts that we embed inside of the image to do all the configuration. And then at that point, it's up and running. And the cool parts about these demos, or really at least the testing, is you press launch on the virtual machine, and you sit back, and all of a sudden you watch your Rancher cluster fill up with new nodes, and you watch all of your registrations come in. And that part is really, really satisfying. Also kind of time consuming to show on a live stream like this. So I'll spare you the actual mechanics of it, but the important takeaway here is it is a YAML-based definition, which can go into version control and fall into all of your existing GitOps processes. It is a directory of any outside files that didn't make sense to embed in the definition, which again can completely fit into existing GitOps workflows. And then that's it. Out pops a consistent, repeatable image that, to reiterate the point, is used for multiple nodes. It is not one image per node, because from the very beginning, that was never an option for us, given the scale that we're looking at solving.
I think you did have a demo/session at Susicon, which I think we can link to here during this. When I'm linking the other stuff, wherein you've demonstrated some of this. Yes.
Yes. So I did a talk on, I mentioned earlier, slides. I have them on the side more as a reference, because so I don't forget things I wanted to comment on. I will talk back to this link in a second, but yes, there's a lot of cool stuff out there. So the Suson session, like you said, it's going to be. I don't remember if they finished the recordings yet, but it will be up hopefully pretty soon. We talked about a lot of the stuff I mentioned in terms of its capabilities. The demo showed a quick iteration of running through the CLI tool and the image coming out. And then we focused on the neater aspects of it, which is the multiple nodes booting. So there was 2 VMs booted up, joined their own Kubernetes cluster, had the networking fully configured. And then during that demo, it's snipped away, so it's a lot shorter, but I boot 2 more VMs and you watch them configure their networking correctly, configuring SSH correctly so I can actually get into them and show you it's working, and then register themselves with the cluster. So all of that will be in there, and it's really the same videos I have on the side that I would have shown if I had showed them right now. To the question about the link, yeah, if you, in reality, the GitHub it's an open source first project. So GitHub is definitely your landing point. And that's the correct link that was posted in by community by Susa. Rancher, I'm seeing a lot of things here on my version of the chat. It's you. Okay. Very formal. I like it. But if you go there, you'll see the basic running instructions on the README. You'll see the development instructions if you are so inclined to contribute PRs. And then there's links into our documentation, which there's a guide for building images, which defines all of the different possibilities. I haven't touched on some of the, especially some of the operating system stuff that is not interesting to just read out loud, but NTP configuration, things like that that you would expect you want to do to a server. All of that is included in that building images. We have a light examples directory, which is to say that I created it in hopes I was going to flesh it out, and go figure, kind of ran out of time. But it does have a couple of sample definitions you can use to get started, and then some information on how to run that in a VM for those of us who don't have a ton of hardware floating around. I, myself included, because my manager refuses to approve my request for 5 machines for my basement. I'm not sure why. But otherwise, I've been using VMs for that. Never mind. So yeah, totally ways of using VMs to actually boot these and test this stuff out yourselves. Hopefully that answered your question. That's your starting point. And then from there, you can also look at our Susa Edge offerings, but really the open source project is going to be your starting point.
And also, if you're interested, we are going to demo this again at the working group meeting for CNCF's IoT and Edge working group on 24th July, if I'm not getting the date wrong. I have a calendar invite on there, so I'm pretty sure it's 24th, but please correct me if I've gotten the date wrong.
God, I hope it is, because that's the date I have set up. So
okay, so I mean, that's 2 of us then. So yes, we have that as avenue where you can sort of come in and watch a live demo by Jason. So if that's of interest, please do consider joining on the meeting. I can post in the link to that as well shortly. But one of the last questions that I think I have, not from the live perspective, we spoke a lot about all of this. Now, how does the Edge Image Builder actually integrate into the SUSE stack, the SUSE Edge stack, right? How does that happen? Because we've just released Edge 3.0, and yes, Reese, I think that's the outcome of this session. Jason does need a new manager, but coming back to the
recorded. This is coming back in my performance review. I know it.
But essentially, Jason, do you have any? I mean, you do have thoughts about how it integrates into the Edge stack. So, can you, shed some light on it?
Sure. So the Edge stack is non-trivial to explain. It was, it would be nice if this was a simple mobile app where I can be like, ta-da, here it is. The Edge stack is ultimately built on top of the SUSE suite of products, all the ones I've mentioned so far, with a couple of key Edge components integrated as well. One of them, called Metal Cubed, is used for the bare metal provisioning. Again, you have a list of hardware that's not even powered on, but you know the credentials. You feed that into Edge platform, some magic happens, and it turns on those machines and provisions them. What you use to provision those images can, and we would recommend, should be from Edge Image Builder. That way you can take your image, customize all of your workloads and anything you want on it. So that way when Edge platform boots those nodes and provisions them, they're ready to go. You don't just get a nice blank Linux machine waiting for you to do something on. Great shout out in the chat. So another mechanism is to integrate with it is through Elemental, which is again part of the platform, part of the stack, where if you set up your image in such a way, it will call back to Elemental and register itself. So it's very much across all of the different ways we have of provisioning nodes. Either we know the hardware and we go out and say, here is what you need to have, or we don't know the hardware and we tell the vendor, just install this and it's going to report back to us. Or a third environment of, it is a completely standalone environment. I have a single node or I have a small cluster, or even our management cluster that I want to configure, and you would use Image Builder to do that initial build of the image such that when you boot it, just your Edge stack comes online. So it's interesting. It's an interesting question, an interesting way of answering it, because integrated is almost the wrong word. I understand why you asked that, but it's basically your starting point for a lot of different things you're going to do with Edge platform. Number one being the installation of it in the first place. And then again, we recommend you use this to create the images for all of the nodes that are going to end up being managed by the Edge platform itself. So that way they have the consistent configuration. They're built off of SLE Micro. They have all of your workloads out ahead of time. So once they stand up, they're not immediately eating a whole bunch of bandwidth trying to get provision so they can do something useful. So all of that is a bit of a preparation step with Image Builder, and then you feed it into the stack, and that takes care of actually putting it in the right places and making sure those nodes, once they stand up, are inventoried and available and visible and so forth.
All right. And I don't see any further questions. And I know that we've run over time. And Jason, I know that you have a full day to get back to. So if there are no further questions, I am, going to let our guest get on with his day, and the rest of you as well get on with your respective days. Thank you so much, Jason, for coming on and sharing more insights about the Edge Image Builder project. And for those who are interested, while we're leaving more information in the description and the comment section on LinkedIn, we will also be demoing this, as I mentioned before, on the CNCF working group meeting in 2 weeks from now. So if you're interested in watching and understanding more about the project, please do attend the meeting. I'll be leaving a link on that in the description section to that as well. With that, I think thank you so much, Jason, and we'll see you around to the rest of the audience. Bye.
Thank you for having me. Take care, everyone.